Steamboat Springs, Colorado, population 12,088. A cycling paradise and home to one of cycling's true artisan manufacturers, Moots, the grandmasters of titanium. Last year, they lent me a Route 45 gravel bike to ride in Iceland, and now we're here to see how they practice their craft, how they actually make titanium bikes.
There is no denying that titanium bike frames can be absolutely beautiful. And in this video, we're going to show you just how they're made.
So who are Moots? Well, the company is 24 people strong, and at the core is a team of 17 craftsmen and women who take raw titanium tubing and from it craft bike frames, some of them completely bespoke. Everything is done in-house except for the 3D printed titanium dropouts and the carbon fork, which is made to their specification in the carbon fibre capital of Asia. Now, Moots was started by a guy named Kent Eriksson from a bike shop just down the road, which is still a bike shop to this day, in fact. The original Moots bikes were actually made from steel, but the company swapped to titanium in 1991 when they were looking for a material with greater fatigue resistance in order to make their now famous YBB Softails. They haven't looked back, and they're now one of the longest standing titanium bike manufacturers.
It seems like a strange twist of fate that I've been invited out to see Moots, because actually almost exactly 18 years ago, I knocked on this door completely uninvited. Yes, I was staying in Steamboat with a national mountain bike team, altitude training ahead of the World Championships, which were just down the road, and one afternoon, a little bit bored, I decided to chance my luck and knock on the door. And would you believe it? They very kindly gave me the tour, as they will do to anyone these days if you turn up at 10 a.m. on a Monday, a Wednesday, and a Friday. And here we are on a Friday morning, ready to take the tour. If they'd made that out of titanium, it wouldn't have rusted. The process starts right here with the raw materials. This is some of Moots' considerable stash of titanium. Check this out. Loads and loads of different tube dimensions and wall thicknesses here for obviously different bits of bike, from top tubes to chainstays, but also different styles of bike, mountain bike, gravel bike, road bike, different sizes of bike even as well, so that you can dial in the ride characteristics for bikes for smaller, lighter people and also heavier, stronger riders as well. Cost at this stage for a tube like this is about $28 per foot. So this, it's like $360 of tubing right here. The tubes themselves are sourced from here in the US, and they are what's called 2.5 titanium, which refers to the alloying components, so 3% aluminium, 2.5% vanadium. And it's also a seamless tube as well, which means that it's drawn like this as opposed to rolled and then welded. And that, along with the high quality of the titanium and of the manufacturing process of the tubes as well, means basically that Moots can make the highest quality bikes that they can at the end of the day, but also the whole manufacturing process is more straightforward as well, from hitting the quality control at the end right through to mitering and cutting, which is the next step. You've got your raw materials, you of course now need a design for your bike. So Moots have got loads of different stock options, but you can also get completely custom as well, of which this is a blueprint for one of those. And if you look closely on there, you'll see all the information that the builders need. So you've got the exact tubes that are being used for each part of the bike, so the tube dimensions and also the wall thicknesses. Then you've got the lengths that the tubes then need to be cut to. And then finally, the angles between all the different tubes, because that is where the mitering comes in. So that's where the ends of the tubes are shaped so that even when it's not welded, the whole frame fits together like a jigsaw puzzle. Then you'll also see in this one a yellow card, so that follows the frame through the whole build process and actually ends up with the consumer as well. And it's got a track of which member of staff does which part of the process. So should you wish, you could come back and meet the person that welded your pride and joy and probably get a selfie. So behind me, this is all the machinery for cutting and mitering, but in this room, they also do tube bending, which is part of the process, I'll admit, I've not really thought about, but of course, not all the tubes on a bike frame are straight. You've got your seat stays and your chain stays, they've got a slight bend in, and all the tooling here is actually where that's done. So just here, we can see that there is a top tube about to be bent. So this is from one of the mountain bikes. Because it's a top tube, it's obviously got quite a large diameter. It's also quite thick. So just this short length here is about $100 worth of titanium. And I'm being entrusted with the job of actually putting the bend in it. So the tooling here is CNC machined in-house. And basically, I just have to pull on a lever and it gently bends it into place. So I'm literally just pulling on this lever, right? Okay. Strong stuff. Dusty, am I doing something wrong? Can you show me how it's done? I can't tell you how nervous I am.
All the way to this is
Wow, fair play. So we've just cold worked a top tube. Yes. Each frame's worth of tubes that have been painstakingly cut, mitered and bent, successfully, I might add, are now in one place and ready to roll through to the next stage of the process, which goes through here. But it perhaps isn't what you think it's going to be. Before the tubes get welded, they need to be completely clean, so removed of any kind of oil, be that cutting oil or oil from your skin, because that would then contaminate the welds and leave you with something that's just not quite strong enough. So the tubes get placed inside like a wire rack, a bit like a dishwasher, and then stuck in here in an ultrasonic cleaner. There we go, it's doing its thing in there. Once they come out of there, no human is allowed to touch them unless you're wearing gloves. Now, in order to weld the frame, all the tubes have to be held in the precise locations needed, and that's done using a jig like this. So you'll see that we've got our seat tube and our head tube on here, and actually the first point is our bottom bracket shell. So that's the origin of the whole frame. Everything is built in relation to that. So you can see that our seat tube angle is set, the orientation and location of the head tube is set in relation to the bottom bracket, and also the bottom bracket drop. So that is our rear axle there. And then it's all pieced out tube by tube, starting with attaching the seat tube to the bottom bracket shell there. One thing I want to draw your attention to at this point, because you can't actually see it on a finished frame, is just how tightly those two tubes fit together. The tolerances are unbelievable. I literally can't detect a single gap between our seat tube and our bottom bracket shell, and it's like that on every single junction of the frame. And it's not just an aesthetic thing. You don't want to have to stick loads of filler in between your tubes. It's also a strength thing, so you get a much stronger weld as a result. And also, it then saves time later on down the process because actually the frame is built to much tighter tolerances. It's less likely to warp. Let's talk about welding. Titanium is TIG welded, which is what you can see I'm desperately trying to do right now. It's where a tungsten welding torch heats the metal up to its melting point, in this case 3034 degrees Fahrenheit or 1667 degrees centigrade. In the first instance, the frame is what's called fused together. So that's where the two ends of the tubes are literally melted. So when it's over on the measuring jig, you do what's called tacking. So because the measuring jig is quite restrictive, you can't do a full pass. But the tacks are strong enough that the frame has some kind of integrity, which means it can then be transferred to another jig, and then a full pass weld will be done. Then you do a second pass, which is where a filler is added. In this case, it's another titanium alloy, 6-4 titanium. Now, some manufacturers don't do double pass welding. They will skip out the fusion and just go straight for the filler. But doing a double pass makes it stronger and also much more attractive. Now, there is one slight thing you have to remember when welding titanium, and that is that it's incredibly reactive to oxygen, so it has to be welded in an inert environment. So if you look when it's on the jigs, you'll see that the frames are actually plugged with a tube, and inside that tube is argon gas, which is very inert. And then also you'll see on my torch here, that kind of little, well, I don't know what you want to call it, tube, that's also belching out argon gas as well. So it means that the weld can be carried out in an atmosphere devoid of oxygen. If you do get oxygen in there, it will contaminate the weld and it will leave a brittle finish, which means that after a year or so, your bike might crack. As you can see, in that case, my weld perhaps wasn't the best, but those are some that I was practicing earlier. Fresh from the torch, I believe they say, complete with yellow tickets still attached. You can be forgiven for thinking at this point that this is pretty much the finished article. It's a thing of beauty, but it still needs to go through the finishing process. But before we get there, there's another really important step, and that is to check the alignment. So when you weld a frame up like this, the intense heat that's needed to actually fuse the tubes together can cause the metal to distort ever so slightly and twist. So you need to check the alignment of the frame, and you do that on an alignment table like this one. And so it's incredibly precise, down to thousandths of a millimeter, and you will see whether the frame is straight or not, or whether or not it needs to be what's called cold set. And that's kind of where you gently tweak it back, and so that it is 100% true. What was the exact tolerances? Is it 5,000ths of an inch? There you go. It's a 5,000th of an inch. I mean, that's meaningless to me given that I work in metric, but it sounds really small. Now, I don't know for certain, but that could be a sneak peek at a future design for the finish there. This little beauty of a frame here is currently halfway through the process of anodizing the logos onto the bike. So you see this incredible rainbow finish, and it's achieved firstly by sanding the tube back, treating it, and then running an electric current over the tube in the presence of an electrolyte. And I'm told that you change the color of the finish by actually altering the electric current, and it basically changes the shape of the crystals, and that refracts the light in a different way. And it's a process that's taken literally hours this morning, and we've watched quite a lot of it. It's been brilliant. And this is insanely cool. So instead of it being a brand new frame, this one is actually an old frame that's in for a refurb. So all the original decals will be stripped off, then it'll go into the blasting room and come back out looking like new. It'll then get rechecked for alignment just to make sure it's still 100% true. And there you go. It's like a brand new bike again, even though it's like, I don't know, 5-10 years old.
Now this is cool. We're going to get to see actually inside the blasting room. I feel like an astronaut, communicating by sign language.
It won't escape your notice that a bike frame is not just tubes. There are smaller parts on there, such as these, which are your cable stops or your rear derailleur hanger. All of those things need to be fabricated, of course. And so that's why on this part of the shop floor, there are 4 CNC machines, because as I said at the beginning, almost everything is done in-house. And so if you look around, you'll see all sorts of different components, including one over here, which is a piece of the puzzle I wasn't aware of until just now. So this, which has just been CNC machined, is a thicker piece of titanium tubing. And actually, if you look closely on a frame, you'll see there's a super neat weld here. And so actually you select a seat tube for certain characteristics, and then this is welded on top. You can see it's got much thicker walls on it, and that provides a really sturdy junction for the top tube and the chainstays to be attached to. But the diameter of it is inconveniently not the diameter of a seat post. And so this bit is also CNC machined, although out of aluminium this time, sacrilegious almost, and then that gets placed inside that thicker seat tube. And then if we come over this side, we have one of the few bits that's not made here at Moots. Wow, this is made just up the road. This is a 3D printed titanium dropout. Look at that. So that's where you get a titanium powder made out of 6-4 titanium, which is really hard to work, but super, super strong. And that literally gets printed up layer by layer into incredibly complicated shapes. I mean, look at the inside of that. The reason is, so not all Moots bikes have these, but it's when Shimano introduced their flat mount disc standard, okay? It turned out that that was incredibly difficult to make at the scale that Moots needed, of conventional tubes and then welding that on. So what they did was they outsourced 3D printed dropouts to their specification. That means that actually that super complicated shape can be made relatively easily to allow that perfect placement of a flat mount disc caliper. And it also doesn't hurt that that 6-4 titanium is super stiff as well. Aha, yes, suspension. This is an exploded view of the components that are inside that YBB suspension unit. This, as you can see, is your spring. It's got an elastomer inside, which also has suspension qualities, and that acts as a bit of a damper. Then you have preload adjustment there, and then ultimately that is your slider, and that is your nylon bushing which sits inside the frame. And there you go, simple as that. Old technology, but if it ain't broke, don't fix it. Making bikes can be a fairly energy-intensive process, both in terms of human energy, but also resources that go into actually making the frame itself. And actually, that's something that Moots say they take really seriously, from having solar panels on the roof that contribute up to 15% of the electricity required to run the factory, and right through to the fact that the factory itself has been super well insulated against the Colorado winters, and indeed, this bin that we're sat next to right now. So, in the manufacturing process, a fair bit of titanium offcuts are produced, but rather than just thrown away, they can be recycled. And they drive them over to Denver once a month, and they exchange them for a bit of cash, which they say is not very much, but enough to keep the employees in beer, which seems like a good trade. The very final piece of the puzzle, it comes out of blasting, it's ready to roll, you fit your water bottle bosses, you fit your derailleur hanger, your seat collar, and then the pièce de résistance, the head badge is screwed into place. The hand-painted head badge is screwed into place. It's cool, isn't it? If you thought we were going to leave you there, then no, you are mistaken. Of course, the frame might be finished and ready to get boxed up in this section here and sent off to one very happy customer, but this one here is just about to be ridden. Oh yes, they're lending me a bike. Woohoo! By the way, you'll notice there's a Trek box up there. So I was asking about that earlier, and apparently there's a whole load of Moots owners flying into Steamboat this weekend for a gravel race. Moots very kindly said that they could ship their bikes to them, then they'll build them up for them so that they're ready to roll when they arrive. It's kind of cool if you ask me. Right, let's go. Joining me out on my little ride today is Drew, who's the president of Moots. Drew, first I've got to say thanks so much for inviting us out.
Absolutely.
Secondly, thank you so much for lending me a bike again. Can I take the opportunity, now I've got you out and about, just to ask you a couple of questions?
Yeah, shoot.
So I'm really intrigued. You know, Moots made the switch from steel to tie back in the early 90s. Now, I'm really glad that you didn't make the switch to carbon fiber, but why not?
Yeah, no, that's a great question, one we talk about quite a bit. So our philosophy at Moots has really been simple. We've always wanted to build the best possible bikes we can in-house, and bikes that we think are the best ride quality, most durable, and highest performing bikes that we can make, that we enjoy riding, and we never changed our mind about titanium. So we've seen a lot of cool carbon bikes out there. We no disrespect for that media, but we still feel like we can make bikes that are super lightweight, incredibly durable, fit better than anything else, and ride better than anything else. And so we just never felt the need to change.
Yeah, fair enough. And the other thing is that, you know, there's a lot of talk about modern consumer culture, right? So, you know, people buy products that don't last, and, you know, they flip them over and over again, and companies make products that don't last, so therefore people buy more of them.
Yeah.
How do you guys operate in that kind of environment? Because, you know, titanium by its very nature lasts, you know, the bikes last a lifetime. We've just seen one that's in for its 10-year refresh.
Yeah.
So So how does that work from a business model now?
Yeah, well, it's a kind of atypical business model. So you're absolutely right. We build bikes to last a lifetime. A lot of times when people buy a Moots, they call it their forever bike, to be cliche.
Yeah.
But that's what we do, you know, and like we've always built bikes that we feel have the best durability because that's what we want to ride on. And we want to pass that along to our consumers. It works out well. Fortunately, we have good partners at Shimano, SRAM, et cetera, that keep making new specs and changing the types of components that people are riding. So even though our frame could last for 20 years, 30 years, 40 years even, people are wanting to upgrade still for the latest in technology. So Di2, hydraulic brakes, bigger wheels, bigger tires, all those things, they change as the years go on. So people will come back and buy a new bike.
Drew has unfortunately had to head back to the office to do some proper work. I, on the other hand, have no such constraints. So I'm making the most of the opportunity to hit some of these endless gravel roads that surround Steamboat. If you want to see another epic gravel ride, this time in Iceland, but also aboard a Moots, and you can click through on screen now. Otherwise, make sure you give this video a big thumbs up. Hopefully you've enjoyed it as much as I have.